Hey everybody, good morning. Happy Sunday. Hope that you're doing well. It's a beautiful day out where I live, and I hope the same for you. Today's another Sunday in our continuing series of the Introduction to Statistical Learning book. Today is session number 7. We are on chapter 9, which is amazing to think about. I want to start off by saying how grateful I am for all of you that have stuck with this series and for those of you who continually attend, because it's just amazing to me that we have made this much progress. This is such an interesting book, such a tough book, but I'm really proud of everybody that's, attended. And, I'm also pretty proud of myself for being able to teach this book. It's just, I have so much respect for this book and for the authors, that to be able to teach it is really just kind of something that I'm also just personally proud of. So really, thanks to all of you for making this series possible and for sticking it out. It's been a lot of fun. So I feel like we've run a marathon. All of us have run a marathon, and today's class is like the last turn. You know how you make like that last turn and you can see the finish off in the distance? Like that's where we're at, right? Like we're not there yet. We're not there yet. 2 chapters left. But we can see the finish in the distance, right? Like it's possible, right? It's possible. It's coming up, right? So we have this Sunday together and next Sunday together, and we're done. We can proudly say that we finished out the Introduction to Statistical Learning book. So really proud of all of you guys, and I think all of you should pat yourself on the back. Really interesting. So as usual, we do a little bit of a different conversation on days like today. Obviously always looking for people to say hello and come in when they can, but we don't usually do questions on Sundays. We usually want to do the materials. We're gonna have a pretty interesting discussion today on support vector machines. Really important topic, and as I've always said, we're just adding tools, right? We're adding tools to our toolbox, right? That's all this is. Modeling is just a tool, right? So we're doing tools to add to our toolbox to use at a future time in our professional role as data scientists to help us grow, help us solve different problems at different times, right? But overall, the intent here is to keep on adding tools to our toolbox, understand how to use them, and understand when not to use them, right? That's another big skill of data science, right? Being able to identify what you need at a particular time, super important skill, right? So you're welcome to fill up my chat with introductions, if you, whatever you want to talk about, but no questions, like I said, I don't usually take questions on Sundays. And I know that some of you, kind of just like to hang back, just kind of watch the class, and that's cool too, right? But, we're going to just keep it, nice and collaborative as we always do. I always ask questions of you guys. It's in my nature to teach with the Socratic method, with the different questions that I'll ask and things along those lines. So really appreciate all of you being here. And again, I'm just grateful that we've made it this far. We've come pretty far, guys. We've come pretty far. So really grateful to be able to spend this time with all of you. All right, so again, if you're just joining us, feel free to introduce yourself, or otherwise we'll just get started. We'll get right to the materials. We had a long session last week, right? I think we went for 3 hours, our longest session yet. So maybe we can avoid going that long. I don't know how we're gonna go. Let's see if ChatGPT cooperates this time. But yeah, just another Sunday class, guys. So let's start from the beginning. DevRoy98 says, hello, Dennis. Hey, Dev, how are you? I think this might be your first time attending. If it is, welcome. Feel free to let us know the city, state, province that you're from. Joseph, our good friend Joseph says, happy Sunday, Dennis, and everyone. Looking forward to today's class. Yeah, Joseph, a happy Sunday to you too. I hope you're doing well out there. Sarvesh says, good morning to you, Dennis. Sarvesh from Mumbai, India. Sarvesh, good to see you. I think you've attended every day this week, so really appreciate your continued support, my friend. Yassine, Yassine, I used to say Yassine, our man in Morocco, but apparently you're not the only one. We got like 1 million people in Morocco apparently watching my stream. So Yassine is from Tangier. Welcome, Yassine. Hope you're doing well. You know, Yassine, one day, Yassine, you're going to tell me that you learn more from me than you learn from your professors at university, because I'll put my skills up against most people out there teaching data science. So one day you're going to tell me that. Watch. I can feel it. Rex, our good man from NYC. Hello. Hi, everyone from New York City with love. Well, thank you, Rex. Good to see you, man. Hope you're doing well. M. Shadran, I think this might be your first time attending. If it is, welcome. Please let us know your city, state, province. And I usually don't take questions on Sundays. On Sundays, we usually focus on the class, okay? But feel free to come back on other days. I take plenty of questions. Patrick, where you been? Patrick, we were going to send a search party for you. We were going to send Joseph out there to look for you. Where you been? Good morning, everyone. I hope we're all ready to learn. Yeah, Patrick, I hope so too. Today's an interesting chapter. Interesting chapter today. All right, Dev. So it looks like it is your first time. Welcome. Feel free to let us know, whatever you'd like about yourself, especially, city, state, province. Like to see where everybody's from. Manoj says, good morning, sir. Happy Sunday, everyone. Hey, Manoj, how are you? Manoj, you're from Bangalore, I think? Or was it Mumbai? I think it was Bangalore. So I hope you're doing well, Manoj. Thanks for coming back. You're such a great supporter. Thank you so much. Michael, how you doing, my friend? Happy Sunday, Dennis and everyone. Michael from Benin City, Nigeria. Looking forward to our class today. Yeah, thank you, Michael. I know you've been attending quite a bit, and I know you usually stay for the entire time. So I hope you're getting a lot out of it. Michael, we only have 2 more classes, man. Today and the next Sunday, and that's it. We are done with the book. That is amazing, guys. I'm so excited about that. Really proud of all of you. I'm sorry, I don't know the name. I don't read Arabic. I only speak a little Arabic, but I don't read it. If it's your first time, welcome. I think it might be your first time. I usually don't take questions on Sundays. We usually do the class on Sundays, okay? But feel free to stay for the class or come back on another day. Happy to take your questions, okay? Okay, Dev, thank you for the introduction. I'm from India, currently living in Dublin, Ireland. Okay, very cool. Very cool. Are you studying out there? Very cool, Dev. Welcome and thanks for joining us. Hey, Santine, I think this might be your first time. On Sundays, we usually focus on the class. We are doing the Introduction to Statistical Learning book. So that's what we usually focus on Sundays. So happy to, have you ask questions around the class or, so please feel free to stay. Or you can come back on any other day, really, and I take questions then, okay? Leo, our good friend Leo says, good morning, guys. Now, Leo, we have both guys and girls in this chat. Women 25 to 34 are my biggest growing demographic. I think I'm 15% women now, so good morning, guys and gals. We are an inclusive chat. So thank you, Leo. Glad to see that you're back. Hope that you're well. So Manoj is yes. Manoj is from Bangalore. Patrick says, I've crawled out of my hole to see the sun for a bit. Okay, well, good. Well, you came out for a good reason. I think this class is providing some value. I'd like to think so, So yeah, glad that you're here. M. Shadran says, I'm from Pakistan. Okay, very cool. Thanks. We get a few people from Pakistan and from that part of the world, so welcome. Rohan, you're late, buddy. Rohan's usually first, and now you got all these people ahead of you, Rohan. Hey, Rohan, I gotta warn you, man. I'm growing. This morning, I crossed 3,000 viewers on YouTube. Yesterday, I crossed 17,000 on Instagram. So you're gonna have to hurry, Rohan. More competition, man. You're gonna have to be quick. I mean, look, you were 2 minutes late, and there are like 10 people ahead of you, my friend. You're gonna have to work on it, man. You've lost a step, Rohan. Ahab, our good friend Ahab. Hello, Dennis and chat. Ahab, I know you've been staying for the whole lesson, so really glad to have you back. Hope you're well, my friend. Kartik, thank you so much for joining. I think this is your first time. I usually don't take questions on Sundays. We just focus on the class. Right now, I'm just doing introductions to keep things friendly, but and you're welcome to stay for the class, but I usually do questions on other days. Okay, my friend? Malak says, hello, sir. I'm Malak from Morocco. Malak, welcome. I think it's your first time. You can't just tell us Morocco. Morocco's a beautiful and diverse country, right? You can't just say Morocco. There's like a million cities, a million cool cities in Morocco, right? You got to tell us from where, okay? Mehdi, Mehdi, same comment, my friend. You can't just say Morocco, man. You got to tell us where Morocco. Mahaba says, Mahaba from Malaysia. Cool. Welcome, Mahaba. I think this might be your first time. I don't recognize you. But yeah, welcome. Sahara? Is it Sahara? Sahara says, greetings from Algiers. Cool. Algiers. What country is that in? Is that Algeria? From Algiers. Or is that Morocco? Where is that? Let me know. I'm curious. I can't place Algiers. Yeah, let me know, please. Patrick says, it's amazing to see so many new faces. Yeah, it is, Patrick. Absolutely. Now, Patrick, Joseph, and Rex, who you see in the chat, they're my moderators. They help me out on YouTube, Twitch, and on Discord. And I've been telling these guys, I've been telling them, get ready. Get ready. We're going to be busy. We're going to be busy, guys. Get ready. And I think they're seeing it now. You know, my channel has seen a lot of growth. So thank you to all the new people, and thank you so much to the moderators who help me out on a volunteer basis. So if you see them, you know, give them a shout out. You know, they're volunteering to help keep the chats organized and clean and all that. So, you know, thanks so much to Patrick, Joseph, and Rex for helping out. Really appreciate them. Leo says, that's what I also say to my girlfriend. I don't take questions on Sundays. Nice. I like that, Leo. I like that. Yeah. So that's the theme for today. No questions on Sundays. No questions. Ricardo, our good friend Ricardo, back in here. Ricardo from Atlanta. Thanks for everything, Dennis. Thank you so much, Ricardo. I know you're one of our early supporters, so thank you so much for coming back. Yeah, we're gonna have a good class today, Ricardo. So you picked a good day to come back. Okay, Leo, thank you so much. Good morning, guys and gals. We keep it inclusive on the data science with Dennis chat. Ahab says, it's been so long since I looked at ISL. I stopped at regression because I started getting into NLP, but this is a good chance to get back to it. Yeah, great, Ahab, great. You know, Ahab, it's funny because I've had, you know, a good number of people tell me that. Mostly via private message because I think people are a little bit embarrassed, but generally people have told me, you know, I've had that ISL book on my shelf. I just never read it, but your classes have been great and I picked it up again. A lot of people have been telling me that. A lot of people have been giving me that feedback of, you know, I have the book. I just never used it until I heard you explain it. So I take that as a huge compliment. Because as I told you guys, I pride myself on being able to explain complex things, you know, to anybody. So I take it as a huge compliment. But yeah, I hear this, Ahab. A lot of people are telling me the same thing you are. And you know what? One of the things that I kind of like a similar comment as far as this book goes. And this is, and I'm sharing this because it's a point of pride with me. I'm kind of proud of this, guys. But you know, I did this book during my graduate studies. That means I've had this book for 12 years. Like definitely 10 plus, but probably like 12 years I've had this book. And I used it for my classes. And it was a super hard book. I just remember thinking, wow, that book is like serious, right? Because it is a serious book, you know? It's hard to understand this book outside of an academic setting. And it's so dirty. I mean, I'm embarrassed to show, but it's even dirty because it sat on my bookshelf. And actually it sat in storage, right? Because like, you know, I've moved and things. So it's actually been in storage. Sometimes it's been on my bookshelves. So this book is like super dirty, super like worn down, right? But I've also done a ton of data science in between then and now, right? So I'm taking a lot of pride in being able to come back to this book that was so daunting, so difficult when I first used it. And now when I'm doing the materials for you guys, I have like a whole new perspective on it, right? And obviously the things are coming easier because I'm like, oh yeah, I get that. Yeah, they need this, they don't need this. I've never used this, I use this. Like it's easy for me. Like when I prepare the class materials, I can just devour the chapters super quick. And I've taken that as a point of pride because it's like, it shows me personally how far I've come just in my own data science practice. So I'm going to stop there because I don't want to get all sappy on you guys. But you know, me revisiting this book, just like other people have told me, has also helped me because it shows me how far I've come as far as like putting some of this stuff into practice. And just being able to say like, oh yeah, I get that. Whereas 12 years ago, I was like, oh my God, this book's impossible. What am I doing? I'm going to fail this class, right? So I hear you, Ahab. A lot of people are telling me they're revisiting the book. I'm revisiting the book, and I'm really proud of that. So I'll I'll stop there before before it gets too dusty in my office. Chiraichi says, hello everyone, hope you're doing great. I'm Fadwa from Casablanca, Morocco. Nice. Very cool. Welcome, Fadwa. I think this might be your first time attending. Once again, I have about 1 million people from Morocco in my stream. I don't know why that is, but welcome. Morocco's a beautiful country. I've been to Casablanca plenty of times. I stay out there out in the Corniche in Casablanca, beautiful part of the world. Really enjoy being out there. But yeah, welcome. Michael says, congrats on the growth, Dennis. We all here for it. I appreciate that. Thank you. Yeah, it's been growing like crazy, guys. Gundu says, love your stream, bro. Sorry to drop off. I'll join again. Hey, no worries. And by the way, Sunday is a good day to join on my YouTube because it's a widescreen view. So you're welcome back anytime. We usually go at least 2 hours. So come back later today if you want. But yeah, YouTube is usually a little better format for Sundays. Wasim, our friend in Morocco. Wasim, I can't remember what part of Morocco you're from. Wasim says, hello, everyone. Good to see you, Wasim. I won't say which city I'm from, but it won a countrywide vote as the most boring in Morocco. What? You guys voted on that? Who takes a vote on that? All right, well, maybe somebody else can tell me what that city is. Okay, guys, so in the chat, tell me, in the chat, what is the most boring city in Morocco? All right, tell me in the chat. Ahab, I don't know. From what I know, I'm going to guess it's a northern city, and I'm going to guess you're in the northeast of Morocco. I can't remember what that region is called, but different friends I've spoken with and different things I've heard that the northeast of Morocco isn't exactly lively. It's not Marrakesh, right? So I'm gonna say you live in the northeast, but somebody in the chat tell me what's the most boring city in Morocco. Okay, there's plenty of you in Morocco. Okay, so Ajit says, hello, Dennis. Hey, Ajit, welcome. I think this might be your first time. No, I think you've been here before, so welcome. Michael says Algiers is in Algeria. Okay, I thought so. I just couldn't exactly place it. Okay, Malak says, yes, it's my first time. I'm from Rabat. Lots of people from Rabat in here. Quite a few people from Rabat. Okay, so Sahara says, Algiers is the capital of Algeria. Cool. Welcome, Sahara. Ajit says, hello, Ajit this side. Nice. Welcome, Ajit. Ajit says, no, it's my first time. Okay, Ajit, welcome. Yeah, lots of growth on YouTube, so glad to have you here. Anthony Washington says, first time here, just finished my master's in DS, trying to break into the field. Cool, Anthony. Let us know where you're from. We always like to share our city, state, province. Ahab says, but I wasn't just reading. I literally filled a whole notebook with notes, and I'm just at the regression chapter. Well, I think we did regression in like chapter 3. So feel free to go back to the replays, Ahab. I put those replays up and, you guys can watch it part by part. Mahmoud says, hello, sir. I'm Mahmoud from Egypt. I just started learning AI. Cool. Welcome, Mahmoud. You're in the right place. You're in the right place because I try to keep things accessible and keep things, bite-sized for everybody to understand it. And today's chapter is going to be very bite-sized too, okay? Yeah, so Ahab, we're going to figure out what city was it Ahab or Wasim that wouldn't tell us? No, I think it was Ahab that wouldn't tell us. But yeah, all the other Moroccans in the chat can help me figure out which is the most boring city in Morocco. I can't believe you guys voted on that. Rex will take care of that message. Ajit, my first time as well from India. Okay, cool. So Wasim says, I would assume Kenitra is the most boring, but I don't agree with that. Where is Kenitra? Help me figure that out. But like I said, I'm guessing that he's referring to a city in the northeast of Morocco. That's what I've heard, right? I mean, I'm not saying I'm an expert on Morocco, but that's what I've heard. But yeah, so guys, that's all the introductions I'm seeing. If you're not introducing yourself, that's okay. You might be shy, but I know that I do have a lot of new followers on both Instagram and on YouTube. So thank you so much for being here. If you're looking to learn machine learning, AI, and all that, it's you're in the right place. I try to produce things that are bite-sized. This book is where professional data science begins. So if you're learning this book and you're watching here, you're on the right track. Forget the tutorials, forget the boot camps. This book is where serious data science begins. So Wasim says Kenitra is next to Rabat. Oh yeah, no, that can't be the most boring part of Morocco. No, because that means that you're also near Casablanca and all that. So yeah, that's not the most. I'm sure that there's more boring parts. So I'm going to say Ahab is not from Kenitra. All right, so we'll figure that out later, guys. But I want to get started. I want to get started on chapter 9. And I think that we're going to have a good time with it. So everybody, put your thinking caps on. We're going to have some audience participation. We're going to have some coding, with AI, ChatGPT, all that good stuff. But yeah, let's go ahead and do this. So let me bring up my slides. All right. So for those of you that are new, I always prepare a deck so that you and all of us can talk. I will ask questions, of the chat. Please participate. Don't be embarrassed about your answers. We don't pick on anybody. We don't make fun of anybody's answers. Just collaborate. All right. Talking things out is an extremely important part of the entire, not just data science process, but the entire scientific process. Okay. All right. So here we go. Chapter 9. Chapter 9 of 10. Again, congratulations, guys. We made it. Support vector machines. All right, so audience participation. Let's start off right from the bat. Somebody give me a definition for support vector machines. It sounds like an intimidating topic, right? So give me your elevator pitch, right? As brief as possible. I ask you, what's a support vector machine? Give me your elevator pitch, all right? I'll give you guys a minute. Don't be embarrassed. Just participate. What is a support vector machine? Elevator pitch. Okay, Ahab, thanks for volunteering. Ahab is offering up. I always thought of it as an advanced KNN that doesn't have the same problem of high dimensionality. Okay. Yadu Krishna, welcome. I don't think I've seen you before. Yadu Krishna says SVMs are separating hyperplane. Okay. Anybody else? You can also choose to agree with a person. If somebody wrote something that you like, go ahead and agree with them. It's up to you. Leo says algorithm used for simple classification tasks. All right. Ahab says, so in other words, it does not rely on Euclidean distance. Okay. Leo says, it was the first I've learned in a master's. Really? This is how they start you in a master's program? Interesting. Interesting. Anybody else? Give you guys another 30 seconds here or so. Hey, Leo, I'm curious to know if they're teaching this book in your master's program. So Manoj says it separates the data points by using hyperplane and classification. Okay. SVM is a supervised machine learning algorithm used mainly to separate two classes, using while giving the possibility to tolerate some error, and can be scaled to use nonlinear data. Can be scaled to use nonlinear data. Okay. All right, so Patrick is agreeing with Yassine. Joseph says maybe a type of machine learning model used for classification tasks involving a hyperplane. All right. All right, cool. Anybody else? Last call. Or, you can just choose to agree with somebody. You can say, hey, I like Joseph's answer. I like Leo's answer. Whatever you'd like. Leo says, no, they like to make things harder. Yeah. Some programs will do that. For sure. All right, guys. So, you know what? I think everybody basically gave a really good answer, right? Maybe we're going to fine tune a couple things. But yeah, I think everybody gave a perfectly reasonable answer, right? So if we go to the next slide, and if we go to the next slide. Okay, let me get some of the final answers here. Rohan agrees with Yassine. Yep. And then Wasim says, I think of it as an algorithm that finds the max margin on the hyperplane that separates data points. Okay. Reasonable answer. Again, we're going to fine tune some of these, right? But everybody gave reasonable answers. So if we combine those answers with things that I've written on my screen in the slides, you're going to see them reflected here, right? So people in the chat said it's a supervised method. That's correct. People in the chat said it's a classification tool. That's correct, right? Because it's not really good for scalar data. One of the things I didn't post here, and you'll see why I didn't post it here, but some people also said it's for two classes, for binary classification. And generally speaking, that is also correct, right? So yeah. It's a classification tool based on a plane. Now, people also mentioned planes, and it is based on a plane. And it's for binary data, and it's supervised learning, right? So those four things, generally speaking, do describe support vector machines. Somebody also mentioned that it's similar to KNN, and we're going to talk about that. That's not incorrect. We're going to talk about that. But yeah, collectively, the chat did give a pretty good explanation of SVMs. Now, I have a third bullet point in here. And the third bullet point, maybe it's going to cause some of you guys to turn this off, right? But you know that I give you guys the real world view, right? And the real world view that I've experienced is that SVMs have kind of fallen out of use. They've fallen out of use because, one, classification problems overall are out there, but they're not nearly as common as tools, as algorithm. You're not going to need them as much as algorithms that give you a quantitative output, right? Like the scalar data outputs. And two, how often do you have binary problems? Most of the time, you're going to need a minimum of two classes, right? Sometimes you're going to need a lot more classes, right? So in practice, if I'm being 100% honest with you guys, I've never used SVMs in the real world. You're usually using another tool, most likely neural networks, because neural networks tend to handle, multi-class problems a little more elegantly, right? And the world is not always a binary place, right? And also, when we're talking about hyperplanes, right? Because somebody did mention hyperplanes, right? You're usually talking about something that's linear. And as we've discussed in the past, we don't always live in a linear world, right? So there's just a lot of practical reasons why you may or may not use, most likely not use SVMs a lot in your careers. But again, I hesitated to include that because I know that it kind of biases the conversation a little bit. But as I've always promised you guys, my intent is to bring you a real world view. And the real world view of that is that, there's usually other ways to handle classification problems. Okay? So keep that in mind, kind of keep that in the back of your head. Still an important chapter. I don't want that to draw from the importance of this chapter. It's still important to understand the concept. But again, just being honest with you guys, the real world view, SVMs isn't something that I've really seen a lot from a practical perspective. Okay? Wasim says, isn't classification very important in bioinformatics? Sure. But there's a lot more to classification than SVMs. Don't neural networks do classification? Regression does classification. You use regression a lot in bioinformatics, right? So there's a lot of ways, that you can use classification, right? Don't equate classification with SVMs. There's a lot of tools for classification. Okay. All right. So, in addition to what we've covered, and in addition to what you guys posted in the chat, the authors draw a pretty nice line to help you understand that support vector machines are actually a family of models. And they put together these three models, right? Or these three parts of the family, right? Maximal margin classifier. So that, so by the way, guys, if you remember anything from this class, remember this slide, okay? Maximal margin classifier, you're looking for the single plane that fits your data best. And you want it to fit your data basically exactly as possible. Support vector classifier, you're still looking for a plane, but you're willing to allow some errors to still fit and give you the least amount of errors. So maximal margin, you're looking for the plane with 0 errors. Support vector classifier, you're allowing some errors. And then the third part is support vector machines, where the best fit may not be linear, right? So if you think about those, it's kind of a graduation of what allowances you're giving to your model. Maximal classifiers, you're saying, nope, it can only be one line and that line has to fit the data perfectly. Support vector classifier, maybe we can make some mistakes. We can allow some mistakes if the plane is a little better. And then support vector machine says, well, who says it has to be a plane? It could be anything we want it to be, right? So that's basically kind of what we're going to look at, right? It's kind of like a graduated scale of what you're going to allow. Now, obviously, you're introducing a few more errors along the way, right? That's why the maximal margin exists, because that is like the no error approach. But in some cases, you're saying I'm okay with some errors if it gives me if it's still a reasonable model, right? So that's kind of like what I want you to think about. Like I said, if you remember anything, remember this, because these are the different types of classifiers that are out there. Okay. Wasim says neural networks are hard to interpret, though. Not always. One, they're not always hard to interpret, and two, you don't always need interpretation, right? Not every problem requires interpretation. Depends on the problem. And there are some techniques to make neural networks interpretable. So I don't agree with that blanket statement, right? As scientists, we should always be careful about making blanket statements. So I don't agree with your blanket statement. There's ways around it. Okay. Sahara. I hope I'm pronouncing that right. I think it's Sahara. Sahara says, "What are real life projects where you would typically use SVMs? Classification projects, right? It's all classification tools. So think about projects where you would have like a yes, no, true, false type of decision, like some sort of binary decision. So like a loan application, some sort of credit scoring, really all kinds of things, right? Some sort of industrial measurement for a prediction of failure, things along those lines. But it's basically for binary decisions. Okay. Ahab says you can use regression neural network with a final layer of sigmoid function to turn into a classification, right? I think you can. I don't know about the sigmoid being the final layer though. Yeah, I suppose you could. Yeah, you could. I mean, I think that's maybe adding an extra layer of complexity depending on how you look at it. But yeah, Ahab, you could find yourself to a solution doing that. Leo says, what are your thoughts on simplifying the output for complex problems in binary? I've built some classification models for where it's possible. Yeah, it is possible. Sure, of course. The hard part is choosing the thresholds for what is a fit for a positive fit for your class or not, right? Because a sigmoid function or these outputs, they just give you a probability, right? That's all they give you. But is that probability good enough? You don't know that, right? It depends on the problem. It depends on what you're trying to solve. And sometimes that probability will be dictated to you. Other times you'll have to find it yourself, determine it yourself. So yeah, I mean, it can simplify it to a single number, but what does that single number mean for like a go, no-go decision, right? You know, and we talked a little bit about this, I believe it was like 2 weeks ago, where we talked about how, you know, like I think we were talking around reinforcement learning, right? Where if you set a particular threshold for a binary decision, just because you fix your data you fix your data and you do a reinforcement learning, it still doesn't mean that those outputs are going to rise beyond the threshold that you've set, right? So that threshold that you choose is kind of important, right? Like coming up with that threshold is a little bit of science, a little bit of art, and a little bit of business too, right? Again, depending on what you're trying to solve. So yeah, you can break it down to that, Leo, but what then? You can get to a single number, a single probability, but what then? Okay, so think about that. Yeah, despite the nuances of the data, yeah. Yassine says, I think SVM is strong regarding one versus all classification, like for fingerprint detection. Maybe. I'm not fully educated on what the data for fingerprints looks like, so I really can't fully comment on this. But yeah, I mean, I'm sure that there's use cases out there where it is strong, but how many times are you going to come across those use cases, right? Generally speaking, you know, we don't always live in a binary world. We don't always live in a linear world. The overwhelming problems that you guys are going to work on are going to be multi-class problems. So Ricardo asks, so it's unlike R squared scores. Yeah, it's unlike it. It's definitely not like that, Ricardo. So R squared scores are a reflection of how your testing data fits your model, right? Like what proportion of your data can be explained by the model. But that's more of a scalar output, right? And really R squared scores are almost, I think they're pretty much exclusive to regression, right? When it comes to classification, you're relying more on like your confusion matrix, your true positives, your true negatives, false positives, false negatives, your accuracy scores, your recall and precision, all that, right? So yeah, R squared, we're not really going to talk about today. R squared is really more on the regression side. Okay. Ahab says, actually, I use linear SVC for a text classification problem, thinking it was binary. Wanted to classify permission versus direct questions, and realized I didn't take into consideration non-questions. Yeah. Yeah, Ahab, I think you went through a very, very valuable exercise. But once you go through some of those exercises, you very, very quickly start to realize why neural networks are so powerful for NLP tasks. I mean, I can't say I've read a ton of NLP white papers in the recent past, but I've rarely come across an NLP problem that isn't solved with a neural network, right? I mean, if you're working in NLP, you're basically exclusively working in neural networks. And particularly, you're working a lot in LSTM neural networks, right? If you guys want to find out why and come back to me with an answer, I'll be impressed. But like LSTM neural networks are basically like, like it's hard to do NLP without those, right? I only used it because I had a lot of features due to tokenization. Yeah, but neural networks are perfect for that, right? Like more inputs, like the more a neural network kind of makes sense, right? So, kudos to you for trying different approaches. We should always have an open mind to trying them. But a lot of features is more reason to use neural networks than other things, right? I mean, neural networks are excellent at more features. So, yeah, I mean, valuable exercise, Ahab, don't get me wrong. But NLP dominated by neural networks. And more features, more need for a neural network. I mean, that's just the way it is in the way neural networks are designed and all that, right? So keep that in mind, right? I mean, there's a reason why NLP is dominated by neural networks. Yeah, that was 6 months ago. I'm a tiny bit better now at linear algebra. Yeah, but you don't need that to be good at neural networks. You need to have a frame. You need to understand a framework to be better at neural networks, right? And also how to use them and things like that, right? And for NLP, you need to understand your embeddings and stuff like that. But yeah, I mean, like, if you read most of the stuff out there, like white papers or articles or whatever, there's a reason why neural networks are being used for NLP, right? All right, so good commentary, guys. All right, so let's go on here. Let's talk about the maximal margin classifier. And it's very simple, right? What is the hyperplane that fits our data? That's it. That's all we're looking to find. Not what fits our data best, but what fits our data. Period. Right? That's really what we're out to find. So this is what it looks like. So Sahar, I think you asked earlier, right? What are some of the problems where you would use SVMs? Basically, when your data looks like this, right? When your data looks like this is when you would use an SVM. So The one of the first steps you should be doing for most of your data when you first get it, part of your EDA, should be to start plotting out some of your data, right? Start plotting out what you think. Well, in the case that you know what you're looking to predict, start plotting that out versus potential predictors, and start seeing what the data looks like. And we talked about this when we talked about regression, right? After a while, it kind of becomes a little bit of a pattern recognition exercise, where you can start to kind of lay out parts of your data and say, "Oh, that looks like a x cubed layout, right? Or that looks like a parabola." So same thing here. To answer Sahara's question, this is how your data would look like for you to say, "Oh, I think an SVM problem or SVM model might fit this data," where you have two fairly distinct classes. So for the maximum margin classifier, you're basically looking at what line best fits my data. So just in case you can't see it, the left and right charts are the same in terms of data, right? It's the same data points. The three lines that you see here are three attempts at getting the right fit. So you can see that this is line number 1, and that's a pretty good fit, but tons of errors for this class, right? For the red class. The second line fits pretty good too, and it reduces the errors for the red class, but also introduces a few more for the blue class. And in the third line, the line that's ultimately chosen, which is also reflected on the right-hand side, fits the data, it fits it perfectly, with an equal balance or the most possible equal balance of errors in both classes. So you're still going to make errors. You're still fitting your data in the same way that all your other possible lines did, but it's where you're fitting for the least errors, the least possible error, right? So that's basically what you're trying to show here and what you're trying to do with the maximum margin classifier. And obviously, as you can imagine, you literally have to visualize that there are lines all across this plane here that also fit, right? Like you could literally draw an infinite number of lines between these two. They each have their own level of errors, but the algorithm is telling us that this particular line fits the data best. It still fits it so that there's no errors, and then you're making the least amount of errors with this particular plane. That's it. That's all there is to the maximum margin. But as I say again, it is very, very rare where you are going to find such defined data for your problems, right? Very, very difficult to find something where your data is like this. Another thing you should consider is if your data is so defined, are we not constrained by the fact that the maximum margin classifier is a hyperplane, which means that it's linear? Right? We saw some nonlinear approaches in regression. Couldn't we do a spline somewhere? A spline somewhere? Like imagine if we were able to do this line, but then at this point here, we were to spline it to be able to capture some of the errors here. Or rather to reduce some of the errors here. So what I'm trying to impress upon you is that there are some maximum margin classifiers that you should be trying, as part of your experimentation. But don't forget about regression. Don't forget about spline regression, ridge regression. That might be valid too when your data looks like this. Because remember, it's all about error reduction, right? So couldn't you use a regression method that we've already learned for this? I think you could. Right? But keep that in mind. Keep that in mind that maximal margin classifier is handy, but in the real world, you're probably not going to come across it as often as you think. All right? All right. So what's support vector classifiers? So support vector classifier says, well, we don't have to be perfect with the way we classify data. We might be okay with some errors. How you make that decision is a function of how your data is spread out, right? In the previous example, this data, is kind of sort of clustered together, right? This general area that they show in the left side chart is basically the only place where you can draw a perfect plane, right? Like you really can't draw it down here or up here, right? But, maybe there is other data where you can kind of play with it and say, well, it's okay if we allow this one error or two errors or whatnot, right? So Sahara says, correct me if I'm wrong, but isn't that similar to a multiple regression line? Yes, you could choose to think of it that way. Yeah. Yeah, Sahara, feel free to refer back to our chapter on nonlinear regression. I think that'll give you more information on that. But yeah, you can choose to think of it that way. Sure. All right, so that's basically what support classifier says, right? Maximal, you're looking for 0 errors. What is the plane that gives me 0 errors? And by that, I mean 0 misclassifications. Support vector says, I'm okay with some misclassifications. So this is what that looks like, right? So essentially, as I write here, you can sacrifice accuracy on some observations to help the remaining observations. So I don't think the authors really do a great job of highlighting the difference between these two charts. So this yellow emphasis over here, that's my own emphasis added. Okay, guys? Just so you guys are clear on that. So here, we're basically saying, well, look, if our data looks this way, that's where we're going to go ahead and draw the maximal classifier would tell you that this is the hyperplane you need, right? But just adding that one single point over here in the second chart, look how much you have to move your plane. You've created many more errors, or you've increased the scale of the errors on your blue class just to include this one blue data point, right? Is that efficient? Is that needed? Every problem you're going to be solving is different, but in most cases, no, it's probably not efficient to modify your entire plane just for that one extra data point. Maybe you're okay with the original plane and leaving one misclassified entry here. Depending on your problem, that may be okay, right? Or not, it depends, right? But that's basically what the support vector classifier asks, right? Well, maybe we're okay with 1 or 2 misclassified points. That's basically what you're trying to do here with the differences between the maximal classifier and the support vector classifier. I think on the next chart, they also display this. And again, I'm slightly disappointed with how the authors have kind of laid this out. I think they could have done a slightly better job. So again, the yellow highlight is my own emphasis added, just so we're clear on that, okay? So take a look at this line. So this line here maximizes your accuracy for your red class. You're sacrificing one misclassified red member, and you've properly classified all of your blue data points, but with a lot of potential for error, right? Because you've essentially added a little bit of bias to your algorithm to favor the red class, right? You're gonna be super accurate on your red class, and your blue class, yeah. This other line kind of does the opposite, right? You're kind of optimized for your blue class. You sacrificed one blue data point, and you're still good for your red class, but a lot of noise, right? And then your maximal classifier would tell you that this is the plane. Right? This plane is what helps you include all of the class members properly. And then the same thing over here, right? These two charts are kind of examples of the same item, but I believe there's a couple extra data points here, right? Point 11 and point 12 are new data points, one for each class. Okay. So again, just as before, the algorithm, the math, is in finding what that plane looks like that still minimizes the amount of errors that you're going to make. And that's it. Sarvesh says, this is where we would use regularization, soft margin, SVM. Maybe. Not all projects are SVM, right? And we're going to talk about that a little bit. Not all projects are SVM. Some of them may be maximal, some of them are support vector classifier. It just depends on your data, right? This is why we plot data, guys. This, I hope the greater takeaway you guys are realizing, this is part of the reason why we do EDA. Right? I mean, creating these plots and looking at what your data looks like should be part of your EDA process. So, yeah, you could use it here, but you don't know that going into it. Right? I mean, again, that's one of those things that academics doesn't really teach you. I mean, like, when do you get to these plots? How do you make the determination? So keep that in mind, Sarvesh, right? That it's easy when it's given to you in a book, but how do you do that in the real world? Vishal says, hi, sir. Hi, Vishal. How are you? I think this might be your first time. Welcome. Vishal, feel free to switch over to YouTube so you can see it on widescreen, but, thank you for being here. Okay. All right. So next portion. So now let's talk about support vector machines, right? So in regression, we all saw how we do not live in a linear world, right? So support vector machines help us find nonlinear answers to classification problems. So, question for the chat. Where else did we see nonlinear approaches in regression? There was a name for it. There was a name for the type of regression that we were using to help us with nonlinear problems? So give it to me in the chat. What was a name when we were looking at scatter plots and we were looking for like that same pattern recognition? There was a name for that. What was that name for that nonlinear regression? All right, give it to me in the chat, guys. I'll give you a minute here to think about it. So Surox, I think this might be your first time. So glad you're here. Thank you. How will you handle imbalance? How will you handle imbalanced data? I think you meant unbalanced data. Many answers to that. It depends on the data you're working on. Sometimes you can handle it, sometimes you can't. It just depends. Are you unbalanced because the data is naturally unbalanced, or are you unbalanced because you're sampling? It could be both of those, right? Can you balance your training data just for model training? Yeah, but that can be a little dangerous, right? There are some risks to that. Sometimes you can get more data, other times you can't, depending on the nature of the data. So I wish I could give you a simple answer, but it just depends. But to your point, you should be trying to be getting as balanced data sets as you can, especially if you're talking about binary decision problems. Casual Economist says, I'm not even on this chapter yet. That's okay. That's okay. One, we all learn at our own pace. And two, feel free to go back to my replays. I think you said you're on regression. Regression was part 1. So just start from there. Part 1 and go to 2, 3, 4, 5, 6. And then today you're in 7. And next week you'll be in 8. But yeah, I have all the parts up there on my YouTube for you guys to watch, okay? Casual Economist says, I'm still going to try and hang. Cool. I like that. Positive attitude, guys. I like the positive attitude. You got to stay with it. Okay, so Sarvesh says kernel regression. Yassine says polynomial regression. Patrick says agree with Sarvesh. Joseph says polynomial. Michael says polynomial. Patrick agrees with Yassine. You can't agree with both, Patrick. Come on. Pick a side, Patrick. Christina, welcome. Christina, I think you were here yesterday. Christina says polynomial regression. Okay. Anybody else? Last call. Where else did we see this? Casual Economist coming in strong with a different answer. I'm on log regression. Nice. See, I like that. I like seeing people take a stand. I'm going to go against the grain, and I'm going to say log regression. I like that, Casual Economist. Really, as a side note, guys, I love seeing people go against the grain, because I like to go against the grain, right? I love it, Casual Economist. My favorite story in the world is, the emperor has no clothes, right? It takes guts to be the small child to say, wait a minute, what are you talking about? You guys are idiots. He's not wearing any clothes. I love that, Casual Economist. Good on you, man. All right, anybody else? Last call. Patrick's still deciding whether he's on a kernel regression or polynomial regression. Also, I think stem functions and splines. Okay. All right. So yeah. So generally speaking, what I'm trying to impress upon you is the polynomial side of it, right? However, having said that, Casual Economist is not wrong. A log regression is similar to what I had in mind. The point being that we don't live in a linear world, and polynomials or logs or some sort of transform to our data usually leads to... Patrick has now agreed with a third person. Oh my gosh, Patrick. Yeah, that's funny, Patrick. But the point is that it does lead to other data or to some other non-linear result in our data, right? That's really kind of what I'm trying to get across to you guys. So Christina, Michael, Yassine, all of you around polynomial regression, you have the right idea. Casual economists, same thing. A log regression is indeed an example of a non-linear approach. So that's exactly what leads into this, right? So SVM has this notion of these polynomial kernels. Your kernel is kind of the center of where you want to start. And then the polynomial function determines the shape that you want to draw around that kernel. And that's basically what's illustrated in these charts, right? So again, coming back to the earlier question by Sahara, if your scatter plot looks like this, okay, well now maybe I want to go ahead and use an SVM approach, right? This looks like something that's eligible because I'm seeing some natural patterns that might make sense for that. So here I can go ahead and say, what the authors are trying to illustrate over here is that this dashed line, that's my kernel. And then I can use that as a basis for my polynomial function to create what that group should look like. I'm sorry, I can't remember who, but earlier in the chat, somebody mentioned KNN. KNN is a clustering approach, right? Well, this looks suspiciously like a cluster, right? So these are times where, your SVM and your KNN type of approaches, you kind of start to blend a little bit, right? So maybe, you would try KNN instead of SVM, or maybe you try both, right? It's possible that both of them will give you similar answers. It's possible they'll give you divergent answers, and it's the same data. You never know. Again, depends on your data, depends on what you're trying to solve. But this is basically what SVM is, right? Every other chart we've had to date has been a hyperplane, a linear selection, right? Do you guys see any straight lines on these charts? You don't, right? This is all, this is kind of like the essence, if you will, of SVM. So again, maximal classifier, what is the single best line that doesn't cause any errors? Perfectly classifies everything. Support vector classifier, I'm okay with some errors. SVM, why does it have to be a hyperplane? That's what we're doing here. There's no hyperplanes on these slides, or on these charts rather. Right? That's it. That's really the essence of the chapter. We don't live in a linear world, so we don't have to have models that are linear. They can be polynomials. So these are the notes, right? Support vector machines introduces these K kernels that serve as the center of the formulas, as I said. And the kernels are basically where are those points on the plane where it makes sense to create a group. That's all we're doing. And now, one of the strengths of SVMs is that if we're picking where the kernel goes, then can't you have multiple kernels? And the answer is that you can. So now you can use SVM to go beyond the binary problems. It is possible to have a multi-class approach to to SVM. I can't remember if I have a chart on that or not. I do. So SVMs can be used for classification problems that have more than 2 classes. And again, it's pretty useful in the real world, right? The world is not always binary. And then the lambda tuning parameter comes back. We've seen lambda tuning in other models. And it helps you fine tune the errors that the model makes. Right? We use lambda parameters to help us fine tune the errors that are made by that, by the model itself. Okay? So that's basically it, guys. This chapter introduces that family of 3 that are commonly referred to as the support vector machines, but it's really kind of 3 different approaches to classification problem. All right. All right. So I believe that after this we are ready to go to code. Yeah. So are there any questions before we go into the coding side? Leo says regularization parameters. Yeah, sure, Leo. You can refer to them as that. I prefer to think of them as hyperparameters. Just because to me, you know, they represent something that you can tune and that you can help with your model. So I just always call them, because I kind of use hyperparameters as a blanket statement across all models. Because again, as scientists, those hyperparameters are what creates experimentation. If you think about it this way, if hyperparameters didn't exist, then there'd be nothing to experiment on, right? It wouldn't be a science. So yeah, regularization, hyperparameters, right or wrong, I use those terms interchangeably. All right, so anybody out there with questions? Otherwise, we're going to go ahead and bring in our employee ChatGPT to help us. Are you guys still with me? Give me a 1 in the chat if you're still with me. Give me a 0 if you're lost. All right, you guys are still with me. Good, good. I'm seeing some 1s in the chat. Look, guys, no question that the level of difficulty in our classes has gone up in the past couple of weeks, but you guys have been doing great. Lakshmi, so good to see you. You didn't introduce yourself earlier, Lakshmi. Glad you're here. Casual economist is a 1-ish. So maybe you're like a 0.75 casual economist. But yeah, glad you're here. Look, guys, it's not always going to make sense your first pass through, and that's okay, right? But I'm trying to give you guys the highlights of the chapters, trying to give you guys the real world of the chapters, and then we'll go from there, okay? And by the way, guys, if you still need additional help, you want to talk some things through, please don't forget about our Discord. Our Discord is, increasingly becoming active, right? So we have a couple of different discussions going on there. Lots of people contributing it, different ways. We are up to 165, 67 people. So really lots of good participation. So feel free to join. Link is in your chats. But we have a great community on there. So if you have questions beyond the classes, it's a good place to do it. All right. All right, so let's go. I'm ready for some code. So if you're a veteran from last week, we definitely had some challenges around the data that we were using with ChatGPT, right? Sorry, let me bring up the right screens. Okay, there we go. So I figured that today we would start doing some plotting. Start by doing some data creation and some plotting. Because I think that's going to help us just, one, work with reliable data. And two, I really would encourage all of you to start getting used to looking at plots. Start getting used to looking at different charts. Because at some point, that pattern recognition is super important, right? So let's start by creating our own data. And we're essentially going to try to recreate some of these charts by showing two different classes. Okay? And then we're going to see what code we can write to model those different classes. All right? So we're bringing in our good friend ChatGPT. If you guys need me to blow up anything on the screen or whatever, let me know. But I have my ChatGPT ready to go. I have my Visual Studio Code ready to go, and I have my terminal ready to go. Because remember, guys, professional data science is not notebooks. So we are using an IDE, and then we are executing things in terminal. And then, that way we have control over our code, and our code becomes that much more scalable and deployable when we write, in pure Python, pure scripts. Okay. All right. So let's go to ChatGPT. And let's go ahead and ask for 500 members in each class. Save the data to a CSV file. And then also plot the data, show me the plot, and save the plot. What else do we need to specify here? Data servers and plots. Plots for me, show me the Python to create a data set that has two classes. And we should also add some features, right? That has, let's ask for 4 different features. 4 unique features. 2 classes of So we're going to go ahead and ask for this code, but we didn't specify that we wanted the classes to be distinct from each other. So I'm guessing that we're going to get a really random scatter plot, and that's okay. And it's a good starting point. Okay. So let's copy this code. Let's bring it to Visual Studio. Visual Studio usually makes it a little bit more visible for you guys. All right, what do you guys think? Is this code reasonable? Yeah, so here's the first line of the actual code. What do you guys think? It's using make classification. Where is that pulling that from? I'm guessing maybe NumPy? Oh, okay, sklearn. It's pulling it from sklearn datasets, make classification. Cool. What do you guys think? I think this looks pretty reasonable to me. And it's going ahead and telling us that feature 1 and feature 2 are the ones that it's going to be plotted. I think this looks fairly reasonable. What do you guys think? Patrick says code looks solid to me. Yeah, I think so too. Let's run it. So let's make sure our file is there, which it is. So Python plots.py. All right. So this is what it gave us. What do you guys think? Dennis, why not notebooks? Why not notebooks? Well, because we didn't come from broken homes and live on the street like a pack of dogs. That's why, Leo. Come on, Leo. Yassine says it's creating 4 features, but only 2 are informative. Does that mean the other are not relevant for separating the 2 classes? Maybe. I don't know, Yassine. We haven't really looked at the modeling side of it yet, right? I mean, look, part of the reason why we're doing our own data is to kind of, save us from having headaches, right? I mean, like we did last week, right? And then also because we still have to model it, right? This is all just exercise data, right? It's good for us to kind of let ChatGPT choose it for us, because in the real world, you're not going to have like your choice of data. Like you can't go back to the business and say, no, I can't work with that data. Give me some different data. Like they're going to give you what it is, right? So we don't know. You've seen that life is full of mystery and wonder, right? So we just gotta play the ball as it lies, as we say here in the US. All right, so Leo says LOL. I don't know what you're talking about, Leo. All right, so what do you guys think? Give me some observations here, right? Because look, guys, this is what you're doing in the data science team room, right? You're saying, hey guys, we got this new data from the business. Here's what the scatter plot looks like. Let's talk this out. What do you guys think? Give me some feedback here. What do you see? Yeah, so Leo, in all seriousness, yes, Patrick is right. You can't deploy a notebook, right? That's usually the rule. I know other people will tell you differently, but they're wrong. But look, when you're working in an enterprise, you're talking about working in a scaled environment where your code is going to be distributed across multiple data centers, across multiple load balance servers. They're going to need fast performance out of it in a lot of your applications, so on and so forth. Notebooks really prevent that, right? Notebooks are really more of a study and an experimentation tool, whereas the scripts are going to be something that you can, scripts and programs, by the way, are going to be something you can actually deploy. In other cases, in a lot of cases too, remember that your code is not going to be standalone code. It's probably going to be consumed by another application or another process or something else that is already functional, right? It's already in flight, right? Like they might tell you, hey, we have this great web app, blah, 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 and we need you to write an algorithm for this small portion of the web app. Well, they're not going to change their entire architecture just to accommodate your notebook. The cleanest way to integrate is to say, here's my pure Python script that does what you need, right? So that's why, I encourage people to get away from notebooks, because it's really more of a study tool. It's notebooks were created because they're a convenient way to hand in assignments, right? But as far as these large scalable environments or situations where you are integrating into another existing in-flight project, in nearly every case, you're better off just producing, scripts and programs that are pure Python, okay? Patrick says, I'm seeing 2 Gaussian distributed classes. Yeah, okay, cool. I like that observation. Patrick says some degree of overlap. Okay, Patrick. Tell me about that overlap. What did we just learn? Tell me about that overlap. I think you're hitting on a key point there, right? Josue says, hi, I'm late by joining the boat. Hey, welcome, Josue. I think yesterday was your first day and you're back. So cool. I like seeing that. Welcome. I think you were from Argentina, was it? I hope you're well. So Josue says some points are closer, so try to cluster is complicated if we want exactly division, or maybe to determinate ways to cluster or classify like SVM. Just guessing. Not a bad guess. Michael agrees with Patrick. Yassine says, I think for this data, there's a lot of overlapping points from the 2 classes. I think we'll have irreducible error at some point using only these features. Okay, Yassine, both you and Patrick are using the word overlap. What should that tell you based on what we learned today, guys? Pull on it. I tell my people to pull on that string, right? Dig deeper. You both of you use the word overlap. So what does that tell you? It should tell you something. Yes, you can use notebooks, but on different kind of solution. Coding is not working well because you will normally be running code on company, not only testing your environments. Yeah, Jose. I think I get what you're trying to say here. Yeah, I mean, you can use it locally just as, your own sketchpad, but trying to deploy a notebook to an enterprise corporate environment, that's amateur hour. You definitely don't want to do that. Okay, so you got to get away from notebooks as early as you can in your career. Yassine says we will use the benefit of tolerating some error. Okay. Tell me more, Yassine and Patrick. Guys, I think Yassine and Patrick are hitting on a key point there, right? What does the overlap tell you? There's a big clue in there, right? Or anybody else want to give their opinion? I'll give another little bit here. What else do you guys see? Anybody else? Oh, Lakshmi, you're so close. Overlapping indicates it's challenging to distinguish between the classes, especially in the overlapping region. You're so close, Lakshmi. Tell me more about that. Anybody else? Patrick, there will be multiple possible separating hyperplanes depending on our business needs. Is there? I don't know, Patrick. I don't know if I'm on board with 100% of what you just said. Josue Manuel says exactly, maybe for some testing local as you mentioned, but about the Jupyter notebooks. And yes, second day here. Enjoy the time here. All right, cool. So thank you so much. Appreciate you coming back. Tell your friends, guys. Tell your friends. Atarva says there must be some correlation. Okay, I'm kind of on board with that. Okay, all right. So you guys are so close. All right. So here's what I want you guys to think about. Earlier we agreed, and the authors introduced us to SVM being like a family of 3, right? Yassine, you got it, my friend. You got it as soon as I started. Yeah, you got it. So yeah, Yassine, I'm going to highlight your answer, right? So family of 3, right? Maximal, give me the one single line that makes no mistakes. 2, give me the line that I'm okay with some mistakes. And 3, give me the non-linear line, right? That's maximal, support vector, and support vector classifier and SVM, right? Can somebody show me where the maximal classifier line is? Give me a 1 in the chat if you see a maximal classifier here, or give me a 0 in the chat if you don't see a maximal classifier. So 1 if you see a maximal classifier, and give me a 0 if you don't see a maximal classifier. Christina says, maybe we can use polykernel or RBF kernel to distinguish between these two classes? Maybe, yeah. Yeah. You're on the right track, Christina, but I kind of want to go down the list, right? Because remember, this is what you're doing in the data science team room, right? And we talked about like pattern recognition, right? So, you know, like you should develop an eye for these things, right? So again, give me a 1 in the chat if you see a maximal classifier. Give me a 0 if you don't see a maximal classifier. All right, last call for votes. Most of you are already voting. One if you see a maximal classifier, a 0 if you don't see a maximal classifier. Atarva says first day here. Welcome, Atarva. Glad that you're here. So Wasim says it's not possible to make a maximum classifier. Pratik says that he does see a maximal classifier. So remember, Pratik, 1 if you see a maximal classifier, a 0 if you don't see a maximal classifier. All right, so the majority of you are voting 0. Yeah, and I think you guys are right. So that's where you guys were talking about the overlapping, right? You were dancing around it, right? Overlapping basically throws out your maximal classifier, right? And this is kind of what I meant before earlier when I was talking about how it's really hard to find data that's that neatly laid out, right? And again, I'm putting emphasis on this because this is the process, right? When I talk to you guys about methodology, about data science being a process, this should all be part of your thinking. I'm going to plot some features out and I'm going to just read it. I'm going to take in the data, right? This is me doing EDA, right? So that's the first thing we should think about. Do you see a maximal classifier? No, that's off the table. All right. So let's go to the next one. Support vector classifier. Give me a 1 if you see a support vector classifier. Give me a 0 if you don't see it. And actually, I'm going to move this just a little bit over to make it better for the Instagram folks, if there's anybody on Instagram. That shouldn't mess up anybody on YouTube. All right, so again, guys, give me a 1 if you see a support vector classifier. Give me a 0 if you don't see a support vector classifier. I'm going to move it over just a little bit more for the Instagram people. Hey, Kartik, I usually don't take questions on Sundays, okay? We're focused on the class. You're welcome to stay for the class. You're also welcome to switch over to YouTube where you can see things a little better. Or you're welcome to come back on another day, but I usually don't take questions on Sundays, okay? All right, yeah, so quite a few of you are voting 1. Yeah. We could probably find a support vector classifier, right? And in this case, we might actually find multiple planes, right? I mean, just as we saw from the authors, there's multiple planes possible, right? There's kind of a natural plane right here, just below the 0 mark. But as you can see, there's still gonna be a good number of blue points in the orange class and orange points in the blue class. But yeah, you could find it. Okay, so Josue, I love I love that you're jumping ahead here. Josue brings up a good point. But you have a margin of error if we talk about support vector classifier, right? Because it's not perfect in that case. Or am I far away? No, you're on the right track because that's what I was going to say next. So yes, we can find a support vector classifier. Now, here's the question: is it going to be any good? Maybe not. You know, like I said, for me, my eye is drawn right here, right below the 0 mark. And that seems like a good point. You're going to capture a lot, but I'm still seeing a lot of blue over here and I'm still seeing a lot of orange over here, right? So is a support vector classifier possible? Yeah. Is it going to be any good? I'm not optimistic of that, right? Atarba says we will have to introduce some slides. Yeah, Atarba, you will. So guys, this is really important. This is where you talking to the business and the conversations you have with them and the problem that you're trying to solve matter, right? This is where you take them in, right? Wasim says, a linear SVC is not. You can't say that, Wasim. You can't say that. You can't say that because you don't know what the business problem you're trying to solve is, right? It's possible that you're going to get a 65% accuracy out of this. And guess what? It's possible that the business is going to come back and tell you, great, we're at 45% accuracy right now. So if you can get us to 65, you'll increase our sales by 20%. Wonderful. They may not want you to go further. That happens, guys. There will be times where your work will be dictated and maybe stopped by the business and say, yeah, that model works just fine for us. Right? So you really can't say that, Wasim. You can't make blanket statements like that. Or like we saw before in regression. I know some of you who have been here before have heard this example before, but for those of you that are new, right? If I told you this model is like 80% accurate and it's a model for loan decisions, you might say, okay, we're okay. We're okay with a 20% default rate. That's better than what we do now. Right? And it's okay because we know that when people default, we can always do collections and we can always, we can get that money back somehow, right? But we're okay with 20%. But now I tell you this model is 80% accurate and it decides when a Tesla, when an automated Tesla presses the brakes or not. Are you okay with 80%? Probably not, right? So you really can't make blanket statements like that. You have to know what you're solving, what the business is after. So I see the model. It's not going to be great, but it might be good enough for the business, right? I'm not going to name names, but I've had clients who they take an approach of, maybe you've heard this saying in the past, don't let perfect be the enemy of good, right? So you might have clients or projects or situations where you tell them, hey, look, I got you to 65%. If you give me another 2 months, I can probably get you to 80+%. They're going to say, no. 65% is enough. We don't want to pay you anymore. This is the end of the contract. Thank you very much. That happens, guys. Whether right or wrong, whether good or bad on the business's part, that happens, right? Some people say, hey, that's good enough. I don't need perfection. I need good enough. So it depends. It just depends, guys. You just never know. So Josue says, if we back to the data, we need to understand what features we're analyzing. Yes. You're not incorrect on that. But one, you're introducing the risk of bias coming into your decisions when you do that. You know, bias and domain knowledge. And two, make sure you do that with the business. You shouldn't be trying to interpret features on your own. Your data science team is not a business team, right? You're a tech team. So yes, you're on the right track, but make sure you do it in a healthy way. Sahara says, Sahara, please let me know if I'm pronouncing your name right. Would it be possible to add another dimension in this case? Sure. Excuse me. Sure. Yeah, look, we're just walking through one example, right? But yeah, in a full data science process, you would be trying as many feature combinations as you can. Absolutely. Yeah. Atarva says, according to the business requirement, we can adjust misclassification. I think, yes, you can. That's absolutely right. Yeah. Yeah. So Atarva here is referring to your false positives and false negatives, right? And you can adjust based on feedback from the business. I've had that happen to me before. And the reason I say that is because when it comes to false positives and false negatives, you can usually assign a dollar value to what it costs the business to make that mistake. And in some cases, those values are different enough, disparate enough, where the business will say, I want you to give me a model that's optimized, and it's okay if it's only 70% accurate, but I want that 30% to be more of this error than that error. Atarva, you bring up a great point, because this 100% happens in business, okay? So to illustrate that, you might say, hey, here's your support vector classifier, but here's the mistakes you're making in orange, and here's the mistakes you're making in blue. And your business might come back to you and say, well, you know what? The blue errors cost us $5, but the orange errors cost us $300. So please make sure you actually shade the model. And they're going to ask you to move that line over so that you actually make less of the orange errors because you're minimizing costs, right? So yeah, Atarva, thank you so much for bringing that up. I had forgotten about that. Super important point. That also happens in the real world, where they're going to say, we're totally okay with errors, just make sure it makes these error Y more than error X, because error X costs us a lot of money. Error Y, we're okay taking the loss. So thank you, Atarva. Thanks for bringing that up. I'm just talking about the data we're working with right now. I meant a linear SVC wouldn't be the best fit for the data. There's probably better ways for it, Wasim, but that doesn't make SVC bad for this. SVC may be acceptable in some cases, right? So just be careful with blanket statements. That's really what I'm trying to impress upon you, right? The bottom line is you never know, right? There's very few absolutes in data science and in all of science, right? We as scientists, we should try to avoid talking in absolutes, right? So you really can't make the blanket statements. Jose says, got it. Okay, cool, Jose. Yep. All right. So I think because we've had so much talk on the SVC, let's do it. Let's map out an SVC here. I think that could be fun, right? So we're going to keep this chart, and we know what data we're working with, right? So guys, just for fun, in your mind, envision what the SVC model would look like, because we're going to plot it out, right? So I'm going to guess that the SVC is probably a vertical line, a near vertical line, right below the the 0 mark here. That's what I'm guessing, right? That's just me using my eye. It might have a slight skew. It might have a slight skew to the right because I'm seeing some orange over here. So I think it might be a slight skew to the right. But that's just my view. That's just my bias. You never know until you run the model, right? So let's do it. Let's go back to our ChatGPT. I think we got to close this out first. Yeah, we close that out. I think we saved the plot. Yep, so we saved the plot and we saved the data. Cool. So there's our data, guys, by the way. All right, so let's start a new file. This one we're gonna call it svc.py. And remember, we don't write any code ourselves. We use our employee ChatGPT to help us. Or vector classifier. That best fits the data. Show me accuracy, precision, and recall metrics, and also plot out the confusion matrix, and also plot out the confusion. So we're doing this to help us show what the model is, and then we want to see the data with the model plotted. Finally, show plot of the data with the model also. Okay, I think that's a reasonable prompt there, guys. Oh, I forgot to ask it to save all of that. I should have said to save the plots. Scatter, gonna show plot. Plot save, plot show. I don't think it's saved. I don't think it saved the previous plot though. So let me add that. All right, I'm going to bring this over so you guys can see it a little bit easier. And then we'll walk through the code because this code's a little bit longer. All right, but from what I saw, it looked fairly reasonable. I'm going to close this out. All right, so we're doing it's bringing in a train test split, which makes sense. It's adding some metrics, which makes sense because we're also going to need that. It's reading the classification dataset, which we just created. It's got the same features. It's got the class. It's going to go ahead and do a train test split. The testing size is 0.3. That means we're training on 0.7 of the data. which is okay. Usually you'd probably want to do like a 80-20, but 70-30 is still okay. Create and train the SVC model. Okay, guys, so here's the heart of the code, right? We're using SVC. I'm assuming that's from scikit-learn, right? Yeah, from scikit-learn, right? It's scikit-learn. We're using the SVM family. We're using SVC, so that totally makes sense. Training, testing, so here's where the magic happens, right? In the fit statement, right? And now we're taking the model and running our predictions on our test set. We're calculating all our scores, accuracy, precision, and recall. We're creating our confusion matrix. We're creating the plot. We're showing the plot. Well, we're saving and showing the plot. And then we're going to go, the rest is just plotting out the results. So I think this looks like perfectly reasonable code, guys. I think that they did a pretty good job of creating this. Let's run this. This one is Python, SV. Actually, you know what? I want to make sure they're using a different name. I don't want to lose that previous classification plot. I didn't check the names. Okay, so boundary plot is the first one we're saving. Confusion matrix we're saving. Okay, it added an SVC prefix. That's good. Okay. All right, I think we're good to go here, guys. svc.pot. Okay. Here's my confusion matrix. Where is my other plot? Where's my other plot? That's weird. Maybe Python can only show one plot at a time? Yeah, I think it is only showing one plot. So let me close that out. Okay. Here we go. So we'll do this, and then we'll rely on these numbers to interpret our what do you call it? Our results, right? All right. Okay. I wasn't too far off, guys. That's what I predicted, right? I predicted a near vertical line with a little bit of skew to the right. That's kind of what we got, right? What do you guys think? What's your interpretation here? What does this chart tell you? And actually, if you want to look back here, we have our accuracy, precision, and our recall numbers. Rahul says, Dennis, I believe ChatGPT is still faster in giving the codes, but it doesn't miss some personal requirements as a prone to some error. Yeah, that's okay. That's okay if it gives errors. We're gonna fix it ourselves, right? We still have require some skill. We can be editors, just not writers, right? Oluwasegun says, hello, Dennis. Hey, good to see you back, my friend. Patrick, I didn't even read your comment before saying mine, but yeah, that's why we're code editors and not ChatGPT monkeys. Yeah, absolutely right. Yeah. Rex will take care of that message. Rahul says, we better. Not always. Not always. ChatGPT has written plenty of code for me that I have no interest in writing. I think ChatGPT is still powerful. Josue says, and it's just an example to test. Yeah, that's exactly right, Josue. We're learning, right? We're learning how to prompt the the ChatGPT properly, right? Sahara says we cannot see it here on Instagram. Sahara, I moved it over just a little bit. Or Sahara, if you look in the Instagram chat, I put a pinned comment that has the YouTube link. Feel free to go over to YouTube. It gives you a better view, okay? Patrick says, not a bad intuition. Yeah, actually not bad. Yeah, you know, I know a thing or two. Contingent on the business requirements, I'm happily surprised with this accuracy. Yassine says it's actually better than expected. Yeah, I agree. I you know, and this is why you have to model things out, right? You can eyeball things, you know, and say, yeah, this is what I think it's going to be. But this is why. And I agree with you guys. To have an accuracy of 90%, that's higher than I would have said. I would have guessed more like low 80s, right? But yeah, I mean, maybe there's just not as many, you know, of the orange dots on one side as we thought there were on the other side, right? Right? You just never know. Michael says, can you please change the colors in the code for better visibility? But not bad at all. Yeah, I agree. I mean, really, that's not a terrible model. You know, sometimes you think to yourself, well, gee, if I look on this side, I see a red dot, red dot, red dot, red dot. You know, I don't know about this model, but you kind of forget, right? It's kind of like that human nature to say, well, wait a minute, you're ignoring all the red dots over here, right? You're ignoring all the properly classified classes, right? So you know, this is kind of why you do the modeling and why you come up with empirical numbers, right? So overall, right, if we're focusing on these numbers in the terminal window here, accuracy of 0.90, precision of 0.99, which depending on your use case is excellent, and a recall of 0.81, which again, depending on your use case, might be good enough. Depending on your use case, you know, that might be the lesser of all the errors, right? So yeah, I think we did pretty good, right? And I think that it shows the power of support vector classifiers. We're still on a plane, right? We're still on a plane, right? We haven't gotten fancy with any polynomial math or anything. But that model's not bad. So give me a 1 if you're on board with that. Give me a 0 if you have some other feedback. Sarvesh says the 90% accuracy no, it's for the test data, Sarvesh. It's for the test data. The training data creates the model. The test data is what gives you your metrics. All right, so I'm seeing a couple of 1s in the chat. You guys with me? Are you guys feeling good about this? I'm feeling pretty good about this. You know, we got some data, and we managed to fit a fairly reasonable model. So now the question is, can we improve on this, right? Can we improve on this? Do you guys see, okay, again, coming back to the questions, do you guys see an SVM model here? Anybody see an SVM model here? Or let me ask a more pointed question. How many kernels do you see? What do you guys think? Anybody see any kernels for our SVM? Because that's really kind of like the difference, right? That we're gonna have kernels. Wasim says theoretically we can improve, but I have to try first, like you said, and see the results. Yeah, Wasim. But I'll be honest, I'm a little skeptical we can improve, right? I'm a little skeptical that we can improve because yes, you can, you can kind of make out some kernels, but kernels make mistakes too, right? Yassine says, I see a polykernel. Yeah, sure, but you can always see polykernel, or they're supposed to be polys, right? Murad says 2. Yeah. Murad, I don't think I've seen you before. Welcome, if it's your first time. Latifa also says 2. Yeah. Yeah, I agree, guys. I see 2 kernels too. But when I see the kernels, it's hard for me to imagine a polynomial that can encompass everything, right? Patrick says the overlap is too symmetrical to get any advantage carving one way or another. Yeah, Patrick, I think you're on the right track with that with that reasoning. I think so too, because for example, I'm looking at the orange side, and I see a kernel here, and I can see a reasonable polynomial, but now I have mistakes both to my left. And then I'm also seeing these that would act as outliers to the kernel, right? These are going to be really far from the kernel. So I'm a little skeptical that we can improve, but you never know, right? Wasim says 90% is already good. Maybe it wouldn't be worth to increase the model's flexibility because that would also increase the model's variance. Yes, Wasim, I'm with you on that. I think so too. I think we can find the kernels. But those kernels are going to introduce more errors, like these over here. Like look at this line over here of these red members, of these red class members. Kind of hard to see a kernel encompassing all of those, right? Like there's no reasonable kernel that reaches all the way out there, right? But maybe I'm wrong. Let's do it. Let's plot this out. I think we should plot it, or model it and plot it. Okay, guys. Let's do this. So we need a new file. And this one we're going to call SVM. And yeah, let's go back to ChatGPT. So we can say that code is great. Please use the same code, but this time I want to model with a support vector machine, SVM, just as before, plot and save, plot, show, and save all results. Okay. Let's bring that to Visual Studio. Let's quickly go through this. So same as before, right? Train test split. Using the same classification data set. So this time we're down here, guys, and it's gonna go, and this time we're gonna be declaring our kernels, right? And how it selects our kernels. We didn't have that before, right? If we look at the SVC before, that parameter was not used. I think it said linear. Yeah, it's a linear kernel, right? So the difference in the code is in the kernel, now we're declaring something that's not necessarily linear. But otherwise, I have a feeling that the rest of the code is the same, right? we're doing our fitting. This is where we're doing our testing. Now we're doing our metrics. We're plotting out we're outputting the metrics. We're plotting out the confusion matrix. And then we're plotting out the actual code or the actual chart, right? So I think this all looks very, very reasonable. So this is 83 lines of code. I think SVC was very similar. Yeah, so it's the same lines of code, guys. It literally just changed that one call to the support vector modeling. I mean, that's how easy it can be. Well, let's do this. Let's make sure my file is there, which I think it should be. It is. So now, let me make sure it's using different names. I think it is. Yeah, it's prefixed with SVM, which is great. Python svm.py. Okay. So here's our confusion matrix. And we can kind of get a sense of the confusion matrix by looking at our metrics down here. So we'll go ahead and close this out. Oh, wow. Wow. Look at that, guys. Okay. Okay. What do you guys think of that? Give me some feedback in the chat, guys. Hey, Alpha, so good to see you. Alpha from Sierra Leone. Welcome. So good to see you, my friend. Hope you're doing well. All right, what do you guys make of that? Give me some feedback in the chat. Gonna move this over for my Instagram people. Patrick says it's a poorly drawn straight line. No, it's not. I'm just a polynomial, man. What do you guys think? Okay, Wasim, I like the way you're putting this. The increase in accuracy is very negligible. Changing the kernel just added more complexity to the model. Yep, it did. Now, Wasim, I just wanna adjust your statement a little bit, right? Keep in mind that in the previous model, the linear models, you don't actually have a kernel. It's a linear output, right? So there is no kernel. You only have a kernel when you start getting into like the more clustering approach, okay? So I totally agree with your statement. Just want to adjust your vocabulary there a little bit because there is no kernel until you are doing like the clustering approach. Otherwise, it should just be referred to as a linear approach, okay? And Ava Gavar says scatterplot. Yep, we're definitely working a lot with scatterplots today. And Ava, I think this might be your first time, so welcome. What else do you guys think? Any other feedback in the chat? So a couple things are jumping out at me. One, look at these clusters. These clusters are crazy, right? And that's okay, right? If that's what the model and the data dictates, then that's what you should be using. Second thing that jumps out at me. Yeah, Patrick, yeah, you took the words out of our mouth. Could be highly influenced by outliers. Yeah, I mean, because what did I say before? I said that I was really pessimistic about these out here, right? But look at the model. The model basically explicitly reached out way out there to those outliers just to include them, right? I mean, look at this little chunk here. It basically created this little like edge to the cluster just to include these three, right? And likewise, kind of like in an inverse way, look over here. Over here, the cluster, the algorithm could have gone here. This could have been like an arc, right? But the algorithm decided that it wasn't, there's not enough significant data out there, so it actually brought itself in, right? The reason that's key is because, remember, this is all in train and test data. You're still going to put this out there, right? And there could be outlier data that doesn't fit these clusters. These clusters are kind of like uniquely shaped, right? Is it like, let's look at this region here. Is it possible that you're going to have a data point here? Sure. You've had data points above it and below it, right? What about down here? Could you have data points here? Yeah, you could. You have some that are reasonably close. Just not in your train and test data, right? But in your prediction data, your unknown data, yeah, you could have some points down there. So I'm really encouraged that the model did find these clusters. And look, guys, these are obviously polynomials, and we did it with like no math, right? The library itself handled all the math and the heavy lifting for us. So in that regard, I think this is amazing. This is an amazing result, right? And let me move this out of the way. And we got to pretty good numbers, right? Our recall actually improved just a little bit. But I am a little concerned, as Wasim points out, that it's going to increase the model's variance, right? Like the shape of the clusters themselves kind of add to that variance. Whereas in a linear model, it's a lot more straightforward. You're either to the right of me or you're to the left of me, period, right? So it's almost like a risk reward thing, right? Like personally for me, like I would say, hey guys, we kind of want that binary decision. Otherwise, you're introducing the risk, as Patrick points out, of the outliers. Because now if you're over here, your SVC, your linear would say, yep, you're in this class. And I don't care where you are, just as long as you're to the right of the line. But here, it would say, nope, you're not part of any class. Right? So that's those trade-offs that you're going to have to discuss in the data science team room and with the business. Because again, it's kind of driven by the business needs or the use cases you're actually talking about. Because again, in a lot of cases, you can assign the dollar value to each of these, right? Sarvesh says it's a model with high variance. It has the potential for high variance, yeah. I mean, because on a strict basis, the numbers are good, right? If we look back here on the terminal window, those numbers are not bad. But yes, there is a potential for high variance because of the clusters themselves. Again, you kind of want that binary. You're either to the left of the line or the right of the line. Where you are on the plane, I don't care. I just want you in one of the two classes. So that's where like the SVC kind of shines through, right? Especially here, again, as Wasim points out, it's the same accuracy. Like you're really not gaining anything. You're gaining more risk, if anything else, right? More unseen risk because your future instances, your prediction cycles, will create that risk of falling outside of one of the clusters. Whereas the risk of somebody falling outside of a binary, right, left, of the chart decision is like pretty low, right? But again, these are things that you're going to be discussing with your team, with your business stakeholders, and it all depends on your use, like on your actual use. Okay? All right. Great session, guys. Great session. And you know what? We had a much different experience with ChatGPT this time around. If you were here last week, we had a heck of a time with ChatGPT last week. But, we got through some problem solving. And this week, we got through it error-free. ChatGPT did an excellent job of coding things. So really happy that, everything has gone well today. Really happy with the session. You guys did a great job of asking questions and keeping the conversation going. Like I said, level of difficulty has definitely gone up, but you guys have been great about it. Next week, unsupervised learning. And then guess what? We are done, guys. We are done with the book. All of you should be super proud of yourself. We just turned the corner, guys. We just made the last turn in that marathon run, and we see the finish line. And that finish line is next week, guys. So really, really happy with the way everything has gone. So thank you so much for participating today. Thank you so much for, like I said, I'm just grateful I get to spend this time with you guys and talk about data science, especially on such a beautiful Sunday. So I hope that the weather is good, and I hope that you are well also. So again, I stream every day, 1500 GMT. Really appreciate your support. Welcome to all the new people. I've been getting a lot of new followers, so welcome. I just feel really fortunate that I can do this with all of you. So take care of yourselves, take care of your families, and I'll see you next time.